Okay, so this is section 3.6, and now we want to talk about drawing f and f double prime given f prime. Okay, now, since f double prime is just the derivative of f prime, that, if you've practiced drawing a function and its derivative, that shouldn't be too bad. The real key is going from f prime back to f. And so, suppose I have something like that for my f prime. Now I want to draw f. Okay, well, what you have to remember, okay, here f prime is 0. Here, that's a critical number, first order critical number for f. Critical number for f. And same with that one. Okay, so f has, now, well, I'm going to say a relative max or a relative min. I mean, how do I know that? Well, because here, the value of f prime is negative. All through here, the value of f prime is positive. And so, if f prime was negative, that meant f was decreasing, and then it was increasing. And so, this critical number corresponds to a relative minimum for f. And then this critical number at the right, well, the derivative was positive, so the function was increasing. And then negative, so the function then is decreasing. This is a relative, so that's a relative minimum. This is a relative max for f. So now I've made those notes, I'm going to redraw this thing. So, did something like this. And this is f prime. And so, okay, critical numbers right there. Now, they could be anywhere. And what I need is, I need a relative min here and a relative max there. I don't know where they go. So I can make them both positive. I can make them both negative. I can make one negative, the one negative, the other one positive. What I know is, okay, I need a slope of 0 right there, and f is decreasing to get to there. Then I need a slope of 0 here, and so we do something like that, and then decreasing again there. So here is my function f. And now f double prime, again, it's just the derivative of this function. So if I know how to draw derivatives of functions, I should be able to do it. Again, I'll get a critical number somewhere around here. So f double prime will be 0 there. And if you look at how I drew this, I did pretty well. If f double prime is 0, I should have an inflection point on f. And I do. Right in here somewhere is an inflection point. And so, I think I'm making that work okay. And as I look here, these are all positive. These are all negative slopes. And so f double prime looks something like that. Okay, so suppose another example. Suppose f prime, I don't know, maybe does something like that. Okay, so I left a hole right there. That's f prime. Now, what I see is f prime is positive everywhere. So that means f is increasing everywhere. Okay. Now, but it was undefined right there. And so what could have happened? Well, so f prime, it's a high number and it's getting smaller and smaller and smaller. Okay. So it was steep slopes, positive steep slopes, but then they're getting smaller and smaller and smaller. Okay, because the values are heading towards 0 of f prime. See, so this is, I mean, you gotta, you know, the values of f prime are the slopes of f, and so it was steep positive slopes. Okay, I can draw steep positive slopes, but then they're trailing off. Whoa, I'm not sure what just happened. I clicked something and it made an automatic straight line. Huh, that's kind of cool. Didn't know it could do that. Okay. So it's going like that, but the slopes are getting less steep. Then here, the slopes are still positive, but they're getting more and more steep. And so it maybe is doing something like that. Okay. Now, we've got this undefined right there. And so it could be any sort of thing. You know, these seem to be heading toward the same value. I guess they wouldn't have to, but I just happen to draw them heading toward the same value. So these two slopes should look the same. So I guess if that was undefined there, maybe the function was undefined there as well. Because if I connect it, I don't think I would get a corner. And so I guess, you know, I'm going to leave a hole there and do something like this for f. So there's f. Now, f double prime, well, it appears here, right, that this is concave down, and so f double prime should be negative. Well, the slopes here are negative, or at least I tried to make them that way. The slopes here are negative, and so that would also say the derivative of this function f prime should be, you know, have negative values. And then it's undefined here, and then now this is this has positive slopes. Okay, so it seems like f double prime should be positive then, and here this is concave up, so yeah, it should be. So this is like an inflection point here. But maybe that's where we really see a definite discontinuity is maybe, so we had this concave down with the negative slopes. The negative slopes are getting steeper and steeper, right? The negative slopes were near 0, but they are getting steeper and steeper, so I'm down here like this. But then these are positive slopes that are quite steep. Okay, so they'd be up here somewhere, and they are getting less and less steep. And so here is f double prime, and it is undefined here at this critical number. Okay, so our function would look something like this. Okay, so there's two examples And finally, okay, again, drawing f from f prime. Oh, what haven't we had? Let's see, we could have, say, an asymptote, a definite asymptote on f prime. So we'll put a asymptote here, and maybe this comes down like this and then heads off like that. So this is f prime. Well, so we've got some sort of critical number there, either first order or zero order or something like that. There is also first order critical numbers. That's where f prime is 0. And okay, f prime is positive here and negative there, in there. So positive and then negative. So positive slopes. If I'm drawing f, I could have some positive slopes like that until I get to my critical number, and then I need negative slopes until I get to this critical number where it needs to have a slope of 0. And then positive slopes again. These are all positive numbers. And so it does something like that. And there's f. Oh, I didn't get this side. Let's say that has a asymptote of 0. So these are all positive values. So f needed to be increasing. It had slopes near 0 here. And then very steep slopes out here. Okay, so actually it looks like probably f would look a lot like f prime. So this was f prime. Well, we'll call f looking like that. Slopes near 0 and then steeper and steeper slopes. Now f double prime, well, looking at f prime here, right? The slopes of f prime are 0, near 0 back here toward the left, and then they get steeper and steeper. So f double prime looks, and they're all positive slopes, so f double prime looks pretty much just like f and f prime on that side. Over on the right side of that asymptote, f prime is decreasing, so f double prime should be negative until we get to about here. Or another way to see it is that when I drew f, that was concave down until I got to about here. And so f double prime should be negative, and then becomes 0 because f prime has a 0 slope right there. And then the slopes of f prime are positive, so this should go, f double prime should go positive. And also it's concave up for f. So that would be another indication that this ought to be positive. It's all working out nicely. So there's f double prime. Okay, so there are 3 examples of being given f prime and drawing f and f double prime. So this is something you want to work at a lot, and I'll probably show you something with Desmos that you can also use to help you practice. Okay, so